Hi everybody. Today we're going to go through some more types of polar curves. You already know circles, and we're going to throw those in here today as well. So this graph with the line, this equation rather, this is not something we can do because we're only doing the ones on the calculator. So you can kind of ignore this one. This one is not something you're going to run into because there's no way to change that r to theta. So we won't be able to make that graph. So this is what we had the other day, circles. We know that things like r equals 5, that makes a circle. But we also know that if it has sine or cosine in it, then of course that changes where the center is. So cosine, of course, always has and will continue to go with x, and sine goes with y. Now, today we're going to throw in a bunch more. So we're going to have these these graphs called rows, and really it's just a flower. So anything that looks like a flower, no matter how many petals it has, we're going to call it a rose. Some things that are different and that are kind of important to notice is that in a circle, there's no number in front of the theta. But in a rose, there's a number in front of the theta. That's the only thing that looks a little bit different. It looks like a circle equation, but there's a number in front of theta. That number in front of theta controls how many petals you'll have. And that says right here, if it's odd, so if it's 5, then it's 5 petals. If it's even, let's say we have a 4. That's probably, if we have a 4 in front of there, then we'd only have 2 petals, which isn't kind of a, I guess we would have 8 petals rather, sorry, if there's a 4 in front of there. So you double that number. So if there's a 2, then you'd have 4 petals. If there's a 6, then you'd have 12 petals. Good news is you will not have to graph these by hand. You will have on the screen, when you're asked about this stuff, you'll just pick the shape and it draws it for you. You just pick how long things are, how many you need. So it's not very detailed. It's not very hard to graph like it would be if we were in school. You'd have to graph these by hand. Also, the number out in front of the word, that's really your, obviously you know that's your diameter is 2a, but in a rose, obviously we don't have a diameter. That's the length of the petal, and I'll show you how this works. Now, a cardioid and a limacon, and this is how you say limacon. It's a French word, limacon. That's what that little thing is doing on that C. So we have cardioid, and that sounds like a heart, and it doesn't really look like a heart, but it kind of does, in that it kind of comes in and has a little dent in the actual graph. In a cardioid, we start adding and subtracting. Cardioid and limacons add and subtract. And a cardioid, the numbers match, whether they're sine or cosine. 2 plus 2 sine, 5 minus 5 cosine. That's how you know it's a cardioid. In a limacon, the numbers don't match. And it's how the numbers compare. That's what controls your loop. Some of them have a loop, some of them don't have a loop. We'll go through all of those here in a minute. And we have one more that you'll see, and I'm going to put it over here, and that's called a lemniscate. Lemniscate. And a lemniscate is the figure 8. So it looks like a figure 8. So it's not going to be a rose. It's only going to have 2 loops, and it'll look like this. Your calculator kind of draws it a little bit different. Your calculator kind of draws like the 2 halves, top half and then bottom half. That's a bad drawing, but it does look more like a figure 8. Also with the lemniscate, you might see the figure 8 on the diagonal. So it's not a 2-petaled flower. We won't have that. The smallest number of flower petals we'll have on our flower or our rose will be 3. If you see 2, it's a lemniscate. Now, a lemniscate has a super unique equation in that it is r squared equals a squared sine of 2 theta. Of course, it doesn't have to be sine. It could also be cosine. It doesn't matter which one it is, but it's got that squared number. Now, of course, it's not going to be a squared. It'll be like r squared equals 16 sine of 2 theta. So it's not going to necessarily have the 4 squared, but it is going to have r squared. And on the video that shows you how to use your calculator, I'll show you how to type that in the calculator. So what we're going to do with this is we're just going to run through this without the calculator. There's a lot you can do without the calculator, and it's up to you how you choose to do it. You will be asked what are the names of each one of these graphs. That's one of the main questions that we have. It's a very easy question to ask, so we'll continue to ask that. Now, you don't actually have to memorize this. You can write this down and have it to look at. You could always graph it and just look at it. And so even if you look at this equation right here, you might think, well, I have no idea what that graph is, but here's the sketch. So it's a rose. This one is a rose. So some things about this rose. This rose has 8 petals. And you can tell either by counting them or going, oh, 4 times 2, 8. And then the length of each one is difficult to tell because this is a bad graph, but the length of each petal is that first number. So the length of each petal is 2. So you might be asked to do something like that where you can't really tell because the graph is terrible, but it's the numbers in the equation that tell you. This one is also a rose. And so you can see sometimes when you have odd or even, it sort of changes. Even, just so you know, even numbers always are symmetry with both axes. Odd numbers will be symmetry with one axis. So because this one has a sign in it, it's symmetric with the y-axis. So that one petal is actually cut in half by the y-axis. So this one has 5 petals because it's odd, so it is that same number in front of the theta. And of course, each length of each one is the number in front, which is a 2. Now when the numbers match, this is a cardioid. And if you notice, this is not a polar grid that they gave us. It's just a regular XY grid that they gave us. So it doesn't have to be graphed on a polar grid. The way this works is if you add the 2 numbers together, that's going to be your outside number. So 2 plus 2, that obviously is 4. And this is the far part, or the outside part. So I'm just going to call this the far. I'm just going to put a point right here on 2. Now I know because it's sine, it goes with the y-axis. So that's how I knew to put that 4 on the y-axis. The first number controls your left and right. So the first number is 2, so the opposite direction. So that means we're going to go left 2 and right 2. And it has symmetry with this y-axis, so we know that 0, 0 is an important number. So when you go to look at that graph, and this is a little bit hard to draw when you don't have the polar grid, this is what a cardioid looks like. It just has a little dent in it, and the dent is going to go through 0, 0. Now a limacon are the next two. And a limacon can look 2 ways, with a loop or without a loop. So this one will be a limacon, and it has that little thing on the C. You don't have to put that if you're typing in an answer. But this is the kind with a loop, because the first number is smaller, or the second number is bigger, however you want to look at it. If you add them together, just like with a cardioid, if you add them together, that's going to be your outer loop. Now this one's oriented different because this is cosine. So cosine runs with x, so it's oriented left to right. So 1 plus 2 is 3. That first number still controls the opposite direction. So now we're going to go up and down 1. If you subtract these two things, that controls your inner loop. So 1 plus 2, that's our outer loop. 2 minus 1, I might as well subtract it in the way that gives me a positive number. That's our inner loop. This is supposed to say 1 plus 2. So I know that my inner loop is only 1 big. And so it kind of looks like a cardioid, but then it kind of goes back in on itself. So the way it gets drawn, and I'll draw it kind of in the order of the points, and it goes like that. So that's what it looks like. It's a limacon with a loop. It's very, very similar to a cardioid. Now the limacon with no loop, this is cosine again. And you can tell by the graph that it's oriented left and right because it's cosine. This one does not have a loop. It has symmetry with the x-axis. So we do the 2 plus 1 thing again, and that's going to be kind of our far edge, kind of like a cardioid. Or in this case, I don't really want to call it the outer because we don't really have an inner loop, but it's the far edge of it. We know it also will not go through 0, 0 most likely. When you subtract this, 2 minus 1, this gives us the other direction edge. So we know that this edge goes right through 1. Now this is kind of strange in that it looks like a straight line. It'll look like a straight line in the graph as well. And the front number is your other direction. So our front number is up and down 2. So this straight line, and you can look at your calculator, but it doesn't go the whole way. So this kind of looks like a circle with a flat edge. That's a limacon with no loop. On the top of this is just more of the exact same thing we just had on the front. The front is actually your book. You are going to be asked to do this. You are going to definitely be asked to just name the polar curve. You may or may not be asked to describe the symmetry, but the symmetry is just the way it's, we've been doing this. Sine is y-axis and cosine is x-axis. So here the numbers don't match. So this is definitely a limacon. You won't be asked to specify with or without a loop. You don't have to worry about that. And the symmetry is the y-axis. This next one for number 2, this is actually a circle. And there's no number in front of theta. That's how you can tell, because if you look at this one, it has basically all the same things, different numbers, but all the same parts. This one has a number in front of the theta, so that's what makes this a rose or a flower. So they both have symmetry with the x-axis because they both have cosine in them. Something else that you'd be asked to do is, from some information, write an equation. So when you have a rose, we know that it's pretty simple. There's no adding or subtracting. This says it's symmetry with both axes, which means it doesn't matter if you pick sine or cosine. What matters is that it's an even number of petals, which it is. So if it wasn't even, we couldn't have that. So we know the petal length is 5. You pick sine or cosine, and then we have 4 petals. So we want to take this 4 and divide it by 2 because we want this number in front. We want to double it to get the 4. Now, you could have r equals -5, positive or negative, doesn't matter on the rows. You could have sine of 2 theta. You could have r equals -5 sine of 2 theta. So all of these would work for that particular one. The ones with an odd number of petals, they're a little bit more particular, but even you can kind of do a lot with this. For number 5, we're going to write an equation with a limacon with an inner loop, and it has symmetry with the x-axis. So we know that we're going to use cosine. Also with the limacon, you know there's no number in front of theta. So when we add the two numbers together, that's going to be our outer loop. And when we subtract the two numbers, that's our inner loop. What matters is, we don't care what the numbers are. They did not give us any numbers to use. What matters is the first number is the small one. So I'm going to go 1. You could pick plus 2 cosine, plus 3 cosine, plus 20 cosine. Doesn't really matter. I'm just going to keep it simple and go with 2. So you could do r equals 2 plus 4 cosine. All that matters is you use cosine, and that first number is smaller. How much smaller is up to you, because they didn't give us the details. Now, you're not going to have to do this next kind of problem where you're going to have to graph on an actual polar grid, because all the things that we'll be doing are online, and you won't have to really pay too much attention to where the points go like you normally would. But what you might also have to be able to do is, from the equation, write the graph. So this is a limacon with an inner loop, as you can see. So we know it's going to be r equals. Your loops matter. Now this grid is a little bit weird. It counts by 2s. So we're looking for 2 numbers that add together to give you the outer loop, which is the 12. And then we want those same 2 numbers that when you subtract them, you get the length of the inner loop, which is 2. So I'm thinking 5 and 7. So 5 plus 7 is 12. 5 minus 7 is 2. It doesn't really matter if you do 7 minus 5 or 5 minus 7. What matters is, because it has a loop, the first number has to be the small one. I'm going to move this down here. So we have r equals 5 plus 7. This is symmetry with the y-axis. You can see it right here. So it has to be sine theta. So use your calculator. If you don't know how to use the calculator, watch the video on how to put these in the calculator. On that video, we'll do the lemniscates, and I'll show you how to graph the lemniscates.